Hello and welcome to 5-Minute Math. Today we are looking at lessons learned from the 8th grade STAAR 2024. Specifically, we are looking at readiness standards that across the state of Texas were assessed at 60% or less mastery. So you see these items on the board. We are going to look at each of them, figure out what the students missed, what are some misconceptions, and then what are some instructional implications. So let's start with our lowest readiness standard. This is 8.7b. You see it in reporting category 3, 32% overall mastery. We are using knowledge of surface area to make connections here, and we're looking at lateral surface area and total surface area of all kinds of three-dimensional shapes. Now, typically it ends up being total surface area, and that's what we have here in 2024. We have total surface area on both of the items, number 8 and number 25. You noticed on number 8 here, we had 40% correct. And so remember our surface area, right, is the perimeter times the height plus double the base. And that base is the area of the base. So we have to first identify here that our base is our triangle. So I'm just going to put this 1/2 base times height in there. Hopefully we notice that the 2 times the 1/2 is going to kind of cancel each other out. So we can just do the base times height of the triangle. That base is 12, right? And the height is 8. So really, we're just adding 96 to whatever we can do with the perimeter. Now, the perimeter means the perimeter of the base. So let's change here. I'm going to do that same area, but this time I'm looking for the perimeter. I'm looking for 10. I need this other 10 right here, and I need that 12. So 10, 10, and 12 is going to be 32 times my height is if I stood it up. That's how high it's going to be. So it's going to be that 32 times that 18, and then we're just going to add that 96. So if we did 32 times 18, we are going to get 576 plus that 96, and we are going to get 672. And so that is our answer B. And you notice that only 40% of our students were able to get that correct. Now, only 24% were able to get number 25. I think one of the problems here is that this is a text entry or an equation editor. There's no guessing. You just have to type it in. But we're going to use the exact same formula. We're going to use this area equals perimeter times the height plus double the base. Now, this one's a little bit trickier because since it is a rectangular prism, we need to decide what the base is. So typically, the base is something you're sitting on, so let's make this our base right here. All right, so what is our perimeter of this base going to be? Well, the perimeter is going to be 40 plus 40 plus 34 plus 34. So let's double the 40 plus 34. So that's going to give me my perimeter. My height is going to be my 30. And then we need to double the area of the base. So that's going to be 40 times 34. And that's the tricky part with this is we're getting perimeter here, we're getting area, because it just says the big B. We need to know that that's going to be area rather than perimeter. All right, so if I double the perimeter, right, that's going to be 74, and that's going to be times 2, so that's 148. And then if I multiply that by 30, okay, so this first chunk is going to be 4,440, which seems pretty big. That might throw some students off. And then we're going to get 2 times 40 times 34, and that's going to be 2,720. So I think at this point, students might feel a little bit nervous because the numbers are feeling pretty large. But take a look at our dimensions. Our dimensions are fairly large. So if we take our 2720 and our 4440, we are going to get 7,160. So that is going to be our correct answer. And so that is only 24% of our students that were able to get 7,160. So both problems here asked for the total surface area, right, rather than the lateral surface area. That's a different formula, both of which are available on the formula chart or the reference materials. Definitely the surface area of a triangle can be prism because that base, right, the area of a triangle is 1/2 base times height, but the surface area needs you to double the base, right? It's the perimeter height plus double the base. So two different bases. The lowercase b means just literally the bottom of the shape. The uppercase b means the area of the base. Obviously, that's confusing for students. Um, the numbers used for calculation were fairly simple for number 5, but the text entry definitely added that rigor. So in the white font at the very bottom, you were going to notice some instructional implications here. So some students find the total surface area formula confusing, right? That might necessarily not be the easiest for students. So if we're using a rectangular prism, maybe we can just have them add the 6 faces. You can also have students practice finding both the total surface area, the lateral surface area of shapes, and then practice discriminating between the two. Because if they can take a rectangular prism or a triangular prism and find first the total surface area, then the lateral surface area, they should see that the lateral surface area is always less because it's not finding all of the faces. And then just practice of both at the same time will help them with that discrimination between which of the two formulas they need to use. Next, we're looking at 8.3c. This is in reporting category 3. Only 40.5% overall mastery. You see it was tested twice. And we are explaining the effect of a scale factor on a two-dimensional figure on a coordinate plane with the origin as the center of dilation. So number 10, you see we had 18% partial credit, 44% full credit. Now, how we kind of get our total percent correct here is we take half of our partial credit, that's 9%, add that to our full credit, 44, right? So we're looking at about 53% mastery. So even though number 10 was a tech enhanced item with the drag and drop, that one wasn't the hard one. It was the number 28. But let's look at both of them. So on triangle PQR on number 10, we have both triangles represented here. We've got PRQ moving to P prime, R prime, RQ prime. And so let's just take a pair of coordinates. So let's just take P, right? It's the X of 1, Y of 3, going to P prime. And we have an X of 3 and a Y of 9 right up there. So hopefully we're thinking, okay, we could multiply by 3. Let's see if that holds up with R prime and R. So R prime and R are going to go from 1, 1 to 3, 3. So multiply by 3 still works. And then let's just close it out with Q and Q prime. Q is 3, 1. And then we're going to go to 9, 3. So yes, that is going to work. Now, we do need to get these in the right order. So I need this first one to be 3x and the second one to be 3y. If for some reason you inverted those and did 3y, 3x, they'd both be wrong. So we need that 3x first, that 3y second. As you can see, we did fairly well on that one as compared to number 28. That was the difficult one because you notice only one shape is given. So this new pentagon, n prime, q prime, r prime, t prime, w prime, is not even pictured. All they give us is a new vertex, r prime. They tell us r prime is at 6, 2. So r prime goes right there. That's all we have. Let's look at what we know about r and then what we know about r prime. Okay, so r is going to be 9, 3. R prime, they give it to us at 6, 2. Now, they are getting smaller, so we are going to need to find a scale factor that is going to be less than 1. So we should be able to eliminate b, we should be able to eliminate c, because even though it's a fraction, it is greater than 1. Now, if we're stuck, look, they're giving us, right, that ratio right there as we're looking at our r prime. Now, we do need to invert it there because that's going to give us something larger than 1. but that r prime to r is going to be that 6 over 9, or that 2 over 3, because we can just look at our points there. And you notice that that already gives it to us in lowest terms. So it's going to be 2/3, and that's our answer D. Now, if we want to verify, we just take our R, so that's going to be 9. Let's multiply it by what we think the scale factor is. 9/3, or 9 times 2/3, that's going to be 18/3, which equals 6. So R of 9 turns into R prime of 6 for the x value. The same thing is going to work with the 3 going down to the 2. So that is our answer D. You notice we had 28% correct on D. So that's just a hair above guessing. So definitely we struggled more when the dilated image was not shown. And that answer distribution on number 28 was very indicative of guessing. So that's our opportunities working with students when one of the images is shown and the other image is not shown. They will obviously have to give you at least 1 point of that second image. And we noticed that the scale factor was not an integer. So on that first one, you just multiplied by 3, but now we had to multiply by 2/3. That was confusing for students as well. So we need to have students work with and without images of the dilated shape. We need to definitely focus on scale factors that are fractions, or it could be decimals, not just integers. And with that, we need to dilate a shape and then ask for a specific vertex. To really notice that the order in which the vertices are named are very important, right? R goes to R prime, W goes to W prime, and that order makes a big difference. And so we're looking more at the order of the vertices, how they're named, rather than necessarily the orientation of the shape. Next, we're looking at 8.10c. This is in reporting category 3. We had 42% overall mastery, and we are looking at translations, reflections, rotations over the x-axis. Now, this is difficult depending on what type of transformation we're talking about. These are rigid transformations, so we're not including dilations here. So a translation, for the most part, is going to be fairly easy. When we're looking at a translation, we're going 3 units to the right on the coordinate grid. So hopefully we see that left and right is our x-axis. And if we're going to the right, we are adding 3. So that's going to be our answer. Simple as that. It doesn't matter what the shape is. If it's to the left or right, it's the x-axis. If it's up or down, it's the y-axis. And if it's going to the right, it's increasing. It's getting a +3. It's number 35. That's the tricky one. It's these rotations of the 90, the 180, the 270. Now, this is one in which students just need to memorize. You see we're at 21%, so this is even less than guessing. So students were trying. We would have gotten a better percentage if we just guessed. What are we doing? I'm going to put a triangle right here. Let's just say RST. And we're going to rotate 270 degrees counterclockwise. So counterclockwise that's 90. That's 180. That's 270. So here's the first thing that our students need to remember. 270 degrees counterclockwise is basically the exact same as a 90 degrees clockwise. So I'm going to put an equal sign, 90 degrees clockwise, because whenever we are rotating, we have 3 different rotations we need to remember, okay? So if we are doing a 90 degree clockwise, which is the one that we did, okay, what we're going to do is we're going to take our XY. They always flip. So your X becomes your Y becomes your X. And then one of them always turns negative. And in this case, since it's the 90 degrees clockwise, which is the same as that 270 degrees counterclockwise, it's the second variable that flips. So it becomes Y negative X. The way I remember that is clockwise is the direction in which the second hand moves on a clock. And so it's the second one that changes. If you end up doing a 90 degrees counterclockwise, which is not what we did. You're doing that same thing. XY is going to flip to YX. But since it's not since it's counterclockwise, it's not the direction that the second hand moves, so it becomes that negative y. So that negative comes first, negative yx. And if you ever do a 180, 180 is the same counterclockwise or clockwise. That's pretty easy. They both just become negative. They don't flip, they just invert like that. So those are 3 rules that we need to help our students remember, and then we need to transform this 270 degrees counterclockwise into a 90 degrees clockwise, which means it's this first one right here, this y negative x. So that is our answer D. But as you can see, only 21% of our students got that correct. So definitely translations are much easier than counterclockwise rotations. This was the most difficult item on the test number 35. 29% of our students chose C. And so let's go back and look. 29% chose C. Now, to be fair, that's at least a rotation. In this case, it's a counterclockwise rotation, but at least we were looking at that. Unfortunately, that was the wrong rotation. These two are reflections, so we should have been able to eliminate both of those simply because we're keeping them in the right order. We're just inverting either the y value or the x value, and those are both rotations over the x or y axis. So when we're thinking about reflections, when we're thinking about translations, they are intuitive. We don't need to worry so much about memorizing them because we can work them out. Rotations that aren't necessarily intuitive, so they should be memorized, and I just kind of walked through that on the previous slide. And remember that 90 degrees clockwise is the same as 270 degrees counterclockwise. So the second they see a 270, they need to flip that into a 90 degrees of the other type. Next, we're looking at 8.12D. And this is calculating and comparing simple interest and compound interest earnings. So you notice that we didn't do very well on either of them. We did a little bit better on 24 than we did on 16. So let's look at both of them. So we're looking at the difference between these two balances. All right, so we've got a 1200 deposit and no additional deposits or withdrawals. Same percentage, 1.5, 1.5. And it's at 4 years. So what we need is we need to just calculate the difference between the balances. Now, here's where it gets slightly difficult. When we are looking at our simple interest, all they do is they give us the formula for the interest, right? Principal times the rate times the time. So we've got 1200, that's the principal. The rate, we need to turn that into a decimal, so 0.015 times, what's our time? 4 years. So if we put all that in, what this is not going to do is this is not going to give us our balance. What we need to do is we need to add our balance back into this because this is simply going to give us our interest. So all of that is $72. Now we need to add that back to what is our initial amount, 1200. So I'm going to put simple interest is going to be 1272. Now let's calculate our compounded interest, and that actually does use the principal and the interest. So when you get your answer on that, then you're actually good. So this is simple interest. So I'm going to put an S right here, and let's do compound interest. Okay, so compound interest is going to be, we've got our principal, we've got our 1 plus our rate, and then we take it to the t power. Okay, so our principal, let's move this down here for a little bit more room. So our principal is 1200. We'll multiply that by 1.015 because we have that 0.015 as our interest rate, and we're going to take that to the 4th power. So let's go ahead and do that. So 1200 times 1.015 to the 4th power, and you don't get a whole lot different. You end up getting, and I'll put compound right here, 1273. 3.64. So if you subtract those two, what are you going to get? You're going to get a $1.64 difference. So that is going to be our answer A. Compounding doesn't really make much of a difference until you get into multiple, like past a decade. Then it starts rising dramatically. So you made $1.64 more if you compounded rather than used simple interest. Now, we have number 24. We had 48% correct, so that's a little bit better than number 16, 37%. We have a deposit here. We've got simple interest, 5.75%, 2 years. What's the balance? So this is very simple. We're going to use that same formula. So the simple interest equals the principal times the rate times the time. So 7912 times, let's do our 0.0575. That's probably the trickiest part, is to get that rate into a decimal. So 0.0575. And then we're going to multiply that by just 2, because we only had 2 years. And so that's going to be 909.88. Now remember, this just gives me my interest. I'm looking for my balance. So I need to add back in my 7912, and I get my 8821.88. We're rounding. You see, it's closest to the nearest whole, so we're going to get that C as our answer, 8822. So for number 16, almost as many chose B, 30%, as the correct answer of C. So let's go back and look at number 16. For number 16, we had 30%. I'll put that in a different color right here. 30% chose that B, whereas the correct answer was 37%, and that chose A. Well, what do we get for B? Right, it's that 7364. That's looking at that the last 4 digits of that compound interest there. So that's interesting that we would get close to that. We saw that 7362. That was the interest there off that $1,200. So that means they did the calculation, at least for account 2, correctly. They just didn't read the answer or the question. The question is looking for the difference. So they did all that work. They calculated that 7364. They didn't subtract the 2. That was a good chunk of students that missed it, not because of calculation error, but because of a reading error. And for number 16, we kind of went back and forth between simple and compound. Obviously, the other problem, number 24, it was just a simple interest, so we didn't confuse the two. So that means that when we are working with them, we need to kind of go back and forth between the two. And finally, that point that I made needs to be reiterated to students when we are looking at simple interest. That formula only finds the interest, not the new balance, whereas the compound interest includes the new balance. So that's the confusing part between these two. So what we need to do is, instead of simply finding the interest, like we did on our second problem, have students practice finding the difference or the sum of 2 different accounts that accrue interest. So we could easily mimic something that's a setup like number 16, to where you've got the same initial deposit at the same time, you're calculating interest both different ways. What's the sum of both accounts, or what's the difference between both accounts? And we need to help students form a conceptual understanding of the difference between simple and compound, really leaning into the exponentials and looking at the graphs and see how it doesn't make that big of a difference initially, but as you get closer and closer to that asymptote, obviously makes a huge difference. And then if we really want to reiterate that, well, we can have them calculate to larger and larger time frames, simple and compound interest to 10 years, to 20 years, to 100 years, with even just a small interest rate, just to see the difference between the two. That will help them, calculating it, graphing it, will help them see that difference, and so then that might help them with that conceptual understanding. Next, we are looking at 8.4C. This is reporting category 2, 44.5% overall mastery. We're looking at finding the slope or the rate of change, and the y-intercept, either from a table or a mathematical real-world problem. And in this case, it is the table for both of these uh, items that we have here, number 15 and number 29. You notice we did a lot worse on number 15 here. So this is a real-world problem or a real-world situation. We've got an artist starting with some paint bottles, and that's the difficult part, right? When we're looking at this, we're looking at a linear relationship, recognizing that this started with some right here. That's your y-intercept, because your y-intercept is the value you have when x equals 0. Because if I make my x 0, then that's going to cancel out the m, because anything times 0 is 0. So that basically makes that go away, and you get y equals b. So understanding that means that we can apply that in a real-world situation. So when you start with something, that's your y-intercept. And so we're asking in this question how many bottles the artist had to start with. Well, first we need to identify the change, the rate of change. So let's just look at the difference in these values here. So if I look at 7 minus 4, that's 3. If I look at 34 minus 25, right, that's going to be 9. So I can get y over x, right? Change in y over change in x. So I've got a 9 over 3. I also, if I want to do these right here, can see I've got 5 right here, and I've got 15 right here. So look what I've got. 9 over 3, 15 over 5. Obviously, they all work out to the same slope, so that's 3. Now, 3 is an answer choice, but it is not the correct answer. I want to know how many bottles the artist had to start with. Well, I need to start with my 4. It's the closest to 0 I have. And you can either do it all at once. You can say, well, I need to go back 4 times. That would be a minus 12 from that 25. Or you can just set it up like this. So 4 is 25. 3 less than that is 22. 3 less than that is 19. 3 less than that is 16, and then I've got 3 less than that is 13. So that is our correct answer of C, 13. Or you could have just said I need to go back 4 times. That's 12. Take that from my 25, which is the closest we have, and that's going to get you your 13. Either way, you got 36% of your students getting C as the correct answer. Now on 29, you've got an inline choice, and so we're just naming these options here. We just need to name what is the slope and what is the y-intercept. And so my slope, right, is going to be, once again, my change in y over my change in x. So I've got a 2 right there, and I've got a 5 right there. So 5 over 2. If I do these ones, right, that's going to be a 4, and that's going to be a 10. Right, so either of those work. We can list that as 5 halves, or if we're going to stick with the decimal theme that we have, let's just make that 2.5. And then what is my y-intercept? Well, if it's 2.5, right, we can do what we did here. We can start with our 5 and go backwards, or we can just multiply multiple times. We can say, well, if I start with 5, I need to go back 2.5, right, and that's going to be 12.5. So I need to take my 12.5 away from that y that's closest to that, because I took it away 5 times, and that's going to be 16.5 minus 12.5, and that's just going to be 4. You also could just plug in y equals 2.5x plus b. Plug in two values, like make the x 11, make the y 31.5. You'd also get 4 as well. So both items required students to use data from a table rather than a graph. Graphs are pretty easy to work with, especially on the y-intercept. The table can be a little bit more difficult. For number 15, the one that was a little bit more challenging for students, almost as many students chose A, 31%, as our correct answer of C, 36%. This was the rate of change or the slope. So they found the rate of change or the slope, but they weren't necessarily finding the B or the y-intercept because they didn't get that from the question. So that's where this problem turns from a math problem to a reading problem. To help students be successful, we need to help them understand what is the question actually looking for. And so in number 29, that was the inline choice. It just plainly asked for the slope and y-intercept. So that's mathematically, whereas 15 asked for it in a real-world context. We need to be able to provide our students opportunities for both. So what are the instructional implications? Well, tables are typically more challenging because they require a lot more calculation. You can get into decimals, which are harder to see on graphs, so graphs tend to be integers. And we need to have students practice. Ask them to turn tables into real-world situations to help them struggle through various ways to note the y-intercept, because that's the challenge there. How do you get from a table in to a real-world situation which they're asking for the y-intercept? Well, if they have practice creating some, just as practice opportunities, that will give them a different insight when they have to help solve them on a STAAR test. So next we are looking at 8.5D. This is reporting category 4. We had 46.5% overall mastery. We are using a trend line to approximate linear relationships between bivariate sets of data. So what we have here is we've got on number 4, you see we only had 31% correct. So that was the hard one. On 39, we did okay. So let's look at number 4. So which prediction of time is best for 90? Okay, so a 90-page report is right there. So that's not necessarily off the graph. But if we wanted to work from the answers rather than the trend line, which is a choice, let's just plot these. Let's just plot these 90 and 95. So my 90 and 95 is going to be right there. Okay, so I can tell you that that is not going to work simply because that is not nearly high enough. So I'm going to X that one out. My 105 is going to be right here. And we're not necessarily off the graph. That looks like it might be a tad low, but I'm not sure. Now, here's the problem. We're getting off the graph. Okay, 125, that's 110. Maybe that's 120, so maybe 125, but now we're just guesstimating. That looks pretty good. Now I'm thinking 155, if that's 100, 110, 120, 130, 40, 150. Okay, so I think we could say 155 is off. So this one looks pretty good, that 125. If I were to draw a trend line, right, I could kind of make it work, but at this point, now I'm just kind of hitting that spot because I think that might be it. What is a better way that we can uh, work with this? Well, and one way that we could work with this is to try to find some items that we think are pretty good representations of these points, right? So I think that this one right here is a pretty good one. So I'm going to call that 3950, right? And I think this one right here is also a pretty good one. So we're just kind of guesstimating what we think good spots are, and that's going to be maybe 5472. All right. So what we could do here is we can find our slope, our rate of change, right? So if I did 72 minus 50 over 54 minus 39, what are we going to get? Well, that's going to get 22 over 15. All right, so how does that help me? Well, if we know that it's direct variation, which we can assume that it is because it looks like it's coming out of the origin, we can say y equals kx, right? And if I want my time in minutes looking from a 90-page report, that means my 90-page report is my x. So I'm simply going to substitute 90 into my 22 over to my equation, and I'm going to multiply that by 22 over 15. So 22 over 15 is about 1.4666. Let's multiply that by 90, and what do you get? You get 132. So y equals 132. Obviously, we're approximating there, but that's also uh, just one way to validate that that 125 is the closest to that. All right, so let's clear that off and let's look at number 39. So we've got 62%. So obviously, we did a lot better on this one than we did on number 4. And so we have a catering company here. We got a scatter plot. We're looking for 45 guests. So that's going to be just a little bit beyond the graph. So if we're counting by twos, the end that's unlabeled is 44. So that 45 is just going to be a hair past that. And so let's do the same thing. Let's go ahead and just plot these points. If my 45 guests are going to be a little bit off the graph, let's plot our 41. I'm just going to put it just a little bit beyond the graph. 39 is going to be really close to that, right below it. 48 is above the graph, something like this. And then 44 is actually going to be right there, just kind of on the edge of the graph. All right, so these two look extremely too low. I could draw a line that kind of makes both work. So let's do this. Let's pick points that we think are going to work. And honestly, this one looks pretty good. And then this one is all by itself, so we need to use that one. So let's use those 2 points. Okay, so that's the top one is 3841, and this one is 3032. All right, let's just subtract. All right, I'm going to get 9 over 8. Okay, so 9/8 is my slope. All right, so let's just put that in. And we say we want our x to be 45, so that's just a little bit more than 1. Right, so 9/8 is just a little bit more than 1, so we want it to be a little bit more than 45. And so 9/8 is 1.125, and then we're going to multiply that by our 45, and we're going to get about 50. And so we're going to see that is about, let's call it 50.6. Now, what's going to get close to that is that 48. So that's going to be that top one. So if we were to draw a line, it would work right about there. And so, yeah, that's going to work. So that's our answer C. All right, so what does this mean for us? Well, on number 4, we had more students choose B, 42%, than the correct answer of C. So we had 42% of our students choose B on number 4. The correct answer, C, only had 31%. And so B was 105, remember, and that was still on the graph. But if you just look at it with all the noise off this graph, you can tell that that's a little bit low. That's not going to hit if we're looking at a line of best fit. And so that's just a visual underestimation of the slope. Both of these items expected students to estimate beyond the graph to some degree, and then the variation in answer selections were minimal. Look how close these were. Like we only had 20-point difference between B and C. And A and C were both incorrect, but there's only a 2-point difference, 2-point difference between those two. And even these two that we were kind of struggling between, 48 and 44, the two ones that were kind of close, that's only a 4-point difference. So we've got to get pretty precise with these. So how do we help our students get precise? Well, what I did was we can have our students select 2 points on the graph that we think best represent kind of the line of best fit, and just estimate a slope based on those 2 points. And then we can use that in a calculation to get a little bit more accurate. And then we can also plot each point, suggest it as an answer, and then visually use that to at least discriminate against some answers that just seem really too high or really too low. So next, we're looking at 8.5i. This is 52.5% overall mastery. So we need to write an equation in slope-intercept form. And so we have a drag and drop here, pretty basic on number 5. We have slope-intercept form, so let's find our slope. Let's find the change in y. So 5 and -1 are 6 apart. 4 and -4 are 8 apart. Right, so that looks like 6 over 8. And let's just try these ones right here. Let's say that's 3, and that's 4. And guess what? We've got it. 6/8, 3/4. 3/4 is our lowest terms. So we're going to grab this 3/4. We're going to put that in there. Now, we need to find our b. So let's just take 2 points and let's plug them in. And so let's just do these two right here. So I'm going to say 5 equals mx. So my m is 3/4, my x is 4. So look what happens. Boom. Those two are going to cancel out plus b. So 3/4 times 4 is just going to end up being 3. So I've got 5 equals 3 plus b. Subtract 3 from both sides. B equals 2. All right, so y equals 3/4 x plus 2. 41% of our students were able to get full credit. That's both items. 10% were able to get partial credit. So that's, if we take half of that, that's 10 points. That's 51% overall mastery. So that's not horrible. Here's the horrible part. 39% of our students, that's almost 2/5 of our students, were not able to just get either of these correct. And probably working with slope-intercept form is the most basic equation that we're working with in Algebra 1. So we've got 2/5 of our students that still need access to how to find the slope, how to find the y-intercepts. We still have some more work to do. Now, when we're looking at 31, they actually did a little bit better. Even though it's in a real-world situation, they got 54% correct. So they're kind of right out, you're not calculating, we're just recognizing, at least for the y-intercept, because look at that, $5 delivery fee, so that's going to be your standard. So y equals, that 5 is just a flat fee, so that's not going to be the rate of change. Now, we have to recognize this as a rate of change, okay? So y is dollars, okay? So what's my change in dollars? My charge in dollars is $7.50. That's the difference there, over my X cookies, 18 minus 12 is 6. So then I just need to figure out what is my 7.50 divided by 6. And that's going to get you 1.25, $1.25 per cookie, plus that $5 delivery fee. So that's going to be our answer, 1.25 x plus 5. And you notice that once we've found that plus 5 as the y-intercept, look, that's the only one that even has that as an option. So we didn't even necessarily need to calculate that. If we could lock in on that 5 as the y-intercept, we could lock in on A as the correct answer without calculating anything else. So what do we have to do? Well, in the first one, we had to generate an equation in slope-intercept form, given data in a table. In the second one, we had to do the same thing, but it was given in a verbal description. Neither slope was an integer, so at 8th grade, we have calculators, which means we're going to have slopes that are fractions. We're going to have slopes that are decimals. And slope of 31 still had to be calculated, even though given as a verbal description. Now, if we really focused in on that, we necessarily didn't need to calculate it, but calculating slope from a verbal description is a little bit more difficult. So we had to recognize that these are our y values, these are our x values, we can subtract those. So that probably tripped up some students. So the use of the formula to calculate slope is essential, right? So I had internalized it, but we need students to know this. Change in x, change in y. You could do it formally like this. You can just take 2 different points and subtract, and just make sure your y is on top and your x is on the bottom. And we might need some extra practice calculating slope from a verbal description. 8.4b, we are graphing proportional relationships, interpreting the unit rate as the slope. So as you can tell, we did pretty well on number 40, but on this other one, we did not. So let's take a look at number 11. So we've got 24 ounces of milk in 18 minutes. And look, they give us ounces per minute. Okay, so when you say ounces per minute, they're giving you the slope right there. Okay, ounces are your y, your minutes are your x. So how many ounces do we have? 24. How many minutes do we have? 18. That's what they give us. Okay, so 24 over 18, right? And unfortunately, that's off the graph just a little bit, so let's simplify that, right? We just cut that in half. We get 12 over 9. We divide that by 3. You're going to get 4 thirds. Okay, so we need a slope of 4/3. So let's see what happens. If I go to my 3, I should be up here at 4. So I'm looking for that point. Didn't see it. See it there on B. 3, really close on C, but it's just a hair above that 4. And I didn't see it on D. So yeah, B looks like it, and we've go over another 3. We're going to go up another 4. We go over another 3. We're going to go up another 4. So that's the key. It's just identifying that slope, and only 42% were able to get number 11, and we are really close on C. Now, 40 was a lot easier, and a worker paints 4 cabinets in 8 hours. We're doing the same thing, and we're doing cabinets per hour, so cabinets per hour, but look what we have here. We've got 4 cabinets, 8 hours, so now we're just looking at 1/2. So a little bit easier to deal with than 4/3. So that means, and look, we've got, look at these two answer choices. C and A are just horizontal lines. So hopefully we have students that look at that and say, nah, I don't think so. So 1 cabinet in 2 hours, right? That's going to be down here on D because you're going to have a pretty shallow slope if we're doing that. B is way too steep. So our answer there is D. So for number 11, both the numbers given for the unit rate are off the graph, right? So we had to simplify that because that 24 and that 18, neither of those ended up being graphable. So we had to simplify that down to 4/3. And all answer selections had positive slopes that are fairly similar, removing the accuracy of estimates. So we couldn't just estimate it. They were all positive slopes, fairly similar, right? A was kind of the shallowest. And obviously, students struggled much less with number 40 because both the numbers are on the graph, and we didn't even necessarily look at that, but we could have just looked at the 4 and the 8 right here, right? We simplified that down to 1/2, but you also could have simplified that. You could have just gone with the 4 and the 8 and just found that. So that was on the graph. And for number 40, very low percentages chose A and C. They're not tripped up by the horizontal line. So that's, even though that might seem like something that's kind of statistical noise, those horizontal lines didn't really mess us up. Students were looking for slopes that were not horizontal. So that's good. So for those that struggle, focus on finding the unit rate first. And then we didn't necessarily do it, but we could have created a table of values, right? So if I found the unit rate over here, let's look at this number 11, right? I could have done 4 and 3. So if my x is 3, and my y is 4, right? Then I could have just created a table of values going up by 3 and going up by 4. Then I could have plotted this, right? So that's just another option for students, is creating a table of values and then plotting those points. That might help them identify the correct graph. Next, we're looking at 8.8C. We have 53.5% overall mastery. This is from reporting category 2. We are modeling and solving one variable equations with constants and variables on both sides. And so you notice on number 18, we are simply solving a representation here with the algebra tiles, though on number 38, we just have the equation itself. So let's take a look. What do we have here over on the left side of number 18? That was the more difficult one, only 48%. Well, hopefully we would have our students notice that there are 2 x's. Then I've got 5 positive ones. That could be condensed into just 5. There are 3 negative x's here, and then I've got 8 positive ones, which can be condensed into 8. So if we can get from our representation to 2x plus 5 equals negative 3x plus 8, hopefully that makes it a little bit more accessible for students. And so we want a positive x, so let's add 3x to both sides. We're going to get 5x plus 5 equals 8. Subtract 5 from both sides. We've got 5x equals 3. And then we simply need to divide by 5, and we get our x equals 3/5. You notice the 3 and the 5 are either positive or negative, and in the numerator or the denominator. So our answer there is A, 3/5. We only had 48% of our students get that correctly. Next, Number 38, we almost hit a 60% threshold, which is our threshold for we basically understand this problem in the state. And you notice the challenge here is I do need to combine like terms. I've got a 2x plus a negative 4x. So if I take a 2x and a negative 4x, I'm going to end up with negative 2x. I still have my 9. And then I've got my x minus 12. Once again, I want to add up so that I get a positive x. So I'm just going to add 2x to both sides here. I'm going to get 9 equals 3x minus 12. And now we're going to add 12 to both sides. And I'm going to get 3x equals 21. And look at that. Our answer is an integer. It's just going to be 7. And we did fairly well on that one. So you could, on number 18, solve without creating an equation. It takes a little bit of work, but you could have just used the algebra tiles here, and you could have added 3x's to both sides. So I could have just added 3x's like this. And I could have taken away 5x's from both sides, right? And so I would have gotten that the 5x's equals 3. And that's what I would have gotten. And then I would have just needed to divide both by 5, and you would have gotten 3/5. So it's possible, maybe not the most intuitive use of it, but we need to at least explain how that works with our students. For number 18, 24% of the students chose C, the incorrect sign. So we got the 3/5. It was these negative 3x's on the right that probably tripped them up. They just chose the wrong side, and that was 24% of our students. So half as many as chose the correct answer. A chose the correct digits, just the wrong sign. And they struggled much less with the purely abstract form, and it had an integer as a solution. Those fractions or decimals always tend to trip students up a little bit. So if students have difficulty with algebra tiles like I did originally, convert them just straight into an abstract equation. For some students, that makes more sense. If not, we can help them work through how to use algebra tiles. And then I did not do it in either situation, but hopefully our students, if they're not sure, could substitute the solution back into the original equation, right? So you just take your 3/5, put it back in there, take your 7, right, put it back in there, substitute it, and make sure it works. Next, for 8.7a, we have 55% overall mastery. We are dealing with volume of cylinders, cones, and spheres. And for number 1, we are dealing with the volume of a sphere. And then in number 38, we have the volume of a cone. So those both require us to use formulas that are on the formula chart. So let's look at first our formula of a sphere. It's kind of a strange one. It's 4/3 pi r cubed, and this is really where we get to know whether our students know what exponents means, because it's not 3r, that's r times r times r, or r to the third power. When we're looking at the volume of a cone, the same as the volume of a pyramid, it's 1/3 base times height. Just depends on what the area of that base is. So let's first deal with this volume of a sphere here, and we notice that they're looking for the radius and they give us the diameter. So that's the one trick here, right? We need 4/3 pi. Now I need the radius, which is half the diameter. So that's going to be 6.5 to the third power. So we're going to do 6.5, and then we're going to multiply that by 6.5, multiply that by 6.5, or we can just plug all this in to the calculator, and we are going to get about 1150.3465. Keeps going on and on and on, and we're just getting the closest, so the answer is going to be A. Now the cone here, the challenge here is the height is 18, they give it straight to us, right? We need to know what this base is. Base is the area of the base. Well, what is the area of a base? So the area equals pi r squared. So turning that big B into the area of the base means that we're going to get 1/3. I'm going to substitute in my pi r squared as my area of my base times the height. Okay, so 1/3 times pi times my radius of 12 squared, and then times height. Now, looking ahead, take a look. They want the exact answer, right? So on the previous one, number one, they said what is the closest? So we rounded to the nearest whole number. We want the exact answer. The only way to get an exact answer is to take pi out and just leave it as separate. So what we're going to do here is we're just going to kind of remove pi, just going to kind of pull it out, and now I'm going to be left with 1/3. I'm going to take 1/3 of 18 because 1/3 of 18 equals 6. So 1/3 of 18 is 6 times 144 because that's really what 12 squared is. So all of that being said, I'm going to get my 864. Now I'm going to bring my pi back in because I kind of took it out. I just simplified the 1/3, the 12 squared, and the 18. And so that is the exact answer. And when you have pi, you have to leave pi outside of the equation in order to get an exact answer. So both problems simply required students to identify the correct formula and solve with a calculator. Obviously, the one with the sphere, they gave you the diameter. You need to use the radius. So number 30 had no visual, provided, and was much more difficult. And honestly, I think the fact that this pi was left out was difficult. So if you were going to take your 864 and then multiply that by pi, you would get 2714. So that's the closest one, but it's not close enough to where you weren't getting messed up. So that might have messed some students up, right? So for number 30, we had almost as many students choose A, 26%, and B, 25% as C. So we had 26, 25, and then we had 38, which means we're getting a lot of guessing. They didn't really understand what was going on. Like I said, we either chose the wrong formula, or I think the fact that the pi was left out kind of tripped up some of their students, so they just ended up guessing, finding something that was close. So even drawing a rough sketch of a cone might help with identifying the correct formula. So if we really did have students that chose the formula for volume of a cylinder or formula for area of a circle, right, drawing the circle of the cone would have helped. And then we need to help students differentiate the different formulas and their uses, whether it be area, whether it be volume, and practice solving, including the pi, practice solving, taking the pi out. We've got 8.5G. This is reporting category 2, 57% overall mastery. So we're close to getting that 60% threshold that lets us feel comfortable. And you see we struggled a lot more with number 3. We need to find a graph that does not represent y as a function of x, right? Each input has one output. So one x leads to one y. You notice we've got a problem right here. Does not pass the vertical line test, so A is out. And we've got B here. B looks fine. We've got C. It's a straight line, and it looks fine, right? I could draw a vertical line through each of these, and we're good. I could draw a vertical line through each of these. Now, if it was a vertical line, obviously it wouldn't work. Now, D kind of messes up because this is a parabola. We don't really mess with parabolas much until we get into algebra, but take a look. I can draw a vertical line through each of those. That is a function. So a correct answer is going to be this A, because that's the one that does not represent y as a function of x. And then I need to plot 2 points here that work for this function if we were to extend this segment. And let's just plot all the points. And you'll see that 3, -6, looks like that's going to continue on that line right there. We've got -1, 6 is not going to work. We've got 1, -6, not going to work. I've got 0, 2, not going to work. And then -2, 4. That does work because that extends that line. So the 3 that did not work ended up having the same x value as the segment that's there, and it would not pass the vertical line test because we're going to hit, we're going to hit, we're going to hit 2 times for all of those. So the correct answer is the first option and the 5th option. And so we had both discrete data and continuous data. And for number 3, 24% of our students chose this one as not the function, and it might have been simply because it was a parabola. And in 8th grade, we really focus on straight lines and linear equations rather than quadratic equations. So that is an opportunity for us to explore various shape types that are functions. And for 37, all we really need to do was extend the line and plot the points. So we could use quadratics, we can use exponentials, we can use absolute value in both continuous and discrete data, not to really explore the attributes of those functions. We don't need range and domain. What we need to do is identify is it a function or is it not a function? You can use all of those graphs to identify functions and non-functions. And then obviously we had two different graphs here, but we also, this standard includes tables, mappings, and ordered pairs. So we don't want to leave those completely because there might be some years in which STAAR gives us those forms to help us identify functions.